Okay, in the today's class we are going to see the first law of thermodynamics current cycling process. So in the last class we have seen what is all about the first law of thermodynamics. So first law of thermodynamics is nothing but is based on the principle of conservation of energy. It is nothing but energy can be neither created nor destroyed, but it can transfer from one form to another. Here, coming to the cycling process. Cycling process is nothing but a process which takes place continuously without any restriction. So here, generally, thermodynamics is concerned about the main two parameters, which is nothing but heat and work. Both are directional quantities. Why? Because when you are supposed to doing some work, there will be a formation of a transfer of energy will take place. So that we are telling it is a directional quantity. So when the energy is transferring, so either it is not possible to get the exact picture of the direction in which the energy is transferred, but we can tell there is a direction during the form energy transfer. So there will be a direction. So that's why we are telling it is a direction quantity. So basically, the complete description of heat and work, it refers mainly the magnitude as well as the direction. So both will take place when there is a transfer of energy. So here we are going to consider a static system which is undergoing to be a cycle of change. You just take a tank which is filled with water. To that tank you just add a stirrer which is connected to a wheel. So now continuously add work to the system so that the stirrer goes on going to rotate. So because of the rotation of the stirrer, there will be a rise in heat which will be produced in the tank. So here the tank, we can take the tank as a system. So we all know the body system and surrounding. The exact motion will be the process is taking place. It is called a system. So the things which are apart from system, which we call that as a surrounding. Here we have some sign conversion which is very important in case of the experiment. So the heat which is added to the system, we can tell there is a positive sign. Similarly, the heat which is rejected from the system to the surrounding. In our case, so because of the continuous rotation of the cycling process, there is a formation of energy taking place. If that energy is rejected to the surrounding, for rejection, what we are going to make is we just take the tank and keep inside a cooling jacket, so that what happens is the heat which is produced in the system, it can be transferred to the jacket. So the cooling jacket, here it is a surrounding. Similarly, the work done by the system to the surrounding is positive. Then work done on the system from the surrounding. In our case, the work done on the system is nothing but the continuous rotation of the wheel is going to keep the stirrer on rotation of the continuous rotation. So we can tell the work which is done on the system will be negative, whereas work done by the system. So work done by the system to the surrounding is nothing but because of the work done by the system only, there will be a heat rejection from the system to the surrounding. So this is a schematic picture for how the heat or the work has been carried out from the system to the surrounding or surrounding to the system. So, as according to the first law of thermodynamics, we can tell because of the cycling process, the work done will be equal to the formation of heat. The last class also I told what is all about internal energy. The energy which is stored in the system by virtue of configuration and the motion of the molecule constituting the system is called internal energy. Basically, for example, if you take a cylinder, you just fill the gas inside the cylinder. If you take a